Of common method to solve system of equation or simultaneous equation. You have graphing method. Plot both equation on the graph to find the intersection point where represent the solution. You have substitution method. Solve one equation for one variable and substitute that expression into another equation. You have the elimination method. Add or subtract equation to eliminate one variable and allow you to solve for the other variable. And you have the matrix method. Use matrices or matrix operators such as row reduction or inverse of a matrix to solve the system. You have other ways, but we're only focusing on these four. System of equation consists of two or more linear equations. This section focuses on only two equations at a time. The solution of a system of linear equation in two variables is any order pair that solve both of the linear equation. To solve system of equation using graphing, step 1. Write the equation in slope-intercept form. Convert each equation to the form like y equal mx plus b, where m is the slope and b is the y-intercept. 2. Graph the equation. For each equation, plot the y-intercept on the y-axis and use the slope to find another point. For example, if the slope is 2/3, move up 2 units and you write 3 units from the y-intercept. And then you draw a straight line through the point for each equation. Step 3. Identify the intersection point. Look at the point where two lines intersect. This point represents the solution to the system of equations. And then you verify the solution. You substitute the coordinates or order pair of the intersection point back into the original equation to ensure they satisfy both. So solve the system of equations. So y equal 2x plus 1 and y equal 1/2 x plus 3. Step 1. So graph the first equation. So the equation is y equal 2x plus 1. So the y-intercept is 0, 1. The slope is 2 up and you go to the right 1. Then the points are 0, 1, 1, 3, and 2, 5. Step 2, graph the second equation. So the equation is y equal negative 1/2 x plus 3. So the y-intercept is 0, 3. So the slope negative 1/2 means 1 down and right 2. So the points are 0, 3, 2, 2, 4, 1. So draw the line and plot the points and draw a line for both equations, a straight line through it. Step 4. Find the intersection. The line intersect at the point 2 to 5. They're going to verify the solution by substituting x2 and y5 into both original equation. For y equal to x plus 1, the answer is 2. When you substitute the 2 and the 5 into the 1/2 x plus 3, it satisfies both again. So solve the following. System of equation 2x minus y equals 6 and x plus 3y equals 10. So the first graph 2x minus y equals 6. So we get 0, 6, 3, 0, and 6, 6. Next, we first going to graph the second equation, x plus 3y equals 10. So you get negative 5, 5, and you get negative 2, 4. 0, and 10 over 3. Then afterwards, we draw a line through it. Look where both graph intersect. It intersects at 4, 2. So although the solution to the system of equation appear to be 4, 2, you still need to check the answer by substituting x equal 4 and y equal 2 into the two equations. So the first equation, it is satisfied. The second equation, it's satisfied. So the point 4, 2 check. So if the solution is true, that means that is the answer.
First step in solving a system of equations graphically is to plot the graph of each equation. In this example, both equations are given in standard form, and the most straightforward method for graphing such equations is the intercept method. So, we will start by finding their x-intercept and y-intercept. Let's begin with the first equation. The x-intercept occurs when y is 0, so replace y with 0 and solve for x. 2 times 0 equals 0. So we are left with 3x equals 12. To isolate x, divide both sides of the equation by 3. Cancel out the 3's. 12 divided by 3 is 4. Therefore, the x-intercept of the first equation is 4, 0. The y-intercept occurs when x is 0, so set x to 0 and solve for y. 3 times 0 equals 0, and we have 2y equals 12. To isolate y, divide each side of the equation by 2. Cancel out the 2's. 12 divided by 2 is 6. So, the y-intercept of the first equation is 0, 6. Now, let's find the intercepts for the second equation. Replace y with 0 to find the x-intercept. 2 times 0 equals 0, and we get x equals -4. So, the x-intercept of the second equation is -4, 0. Set x to 0 to find the y-intercept. Divide both sides by -2 to isolate y. -4 divided by -2 is 2, giving us the y-intercept 0, 2. Now that we have our intercepts for both equations, the next step is to plot them on a graph. For the first equation, plot the x-intercept, which is at 4, 0, and the y-intercept, which is at 0, 6. Then connect the 2 points with a straight line. This line represents the first equation. For the second equation, plot -4, 0, which is the x-intercept, and 0, 2, which is the y-intercept. Then, connect them with a straight line. This is the line of the second equation. The intersection point of these two lines, which is 2, 3, is the solution to the system of equations. We can verify this solution by substituting it into both equations. Substitute 2 for x and 3 for y. In the first equation, 3 times 2 is 6, and 2 times 3 is also 6, which adds up to 12. In the second equation, 2 times 3 equals 6, and 2 minus 6 equals -4. As you can see, both equations are satisfied, confirming that the order pair 2, 3 is indeed the solution. Now, let's solve the second example where the equations are given in slope-intercept form. To graph an equation in slope-intercept form, the most straightforward method is to use the y-intercept and the slope. So, the first step is to identify these values from the equations. For the first equation, the y-intercept is at 0, -2, and the slope is 1/2. For the second equation, the y-intercept is at 0, 1, and the slope is -1. Now let's begin by graphing the first equation. First, plot the y-intercept, which is located at 0, -2. Remember that slope is the ratio of rise over ran. Since the slope is 1/2, the rise is 1 unit up, and the ran is 2 units to the right. Now, starting from the y-intercept, go up 1 unit, then move to the right 2 units. Plot this as the second point. Let's plot one more point. Starting from this point, again, go up 1 unit and to the right 2 units. Then, plot this as the third point. The advantage of the slope-intercept form is that we can easily plot more points and make our graph more accurate. Next, connect the points with a straight line. This represents the line of the first equation. Now, let's plot the graph of the second equation. As we did before, we start by plotting the y-intercept, which is located at 0, 1. Its slope is -1, which is the same as -1/1, right? So, the rise is 1 unit down, and the run is 1 unit to the right. Starting from the y-intercept, go down 1 unit, then move to the right 1 unit. Plot one more point by moving from this point, 1 unit down and 1 unit right. Now, connect these points with a straight line. This is the line of the second equation. The intersection point of the two lines is 2, -1, which is the solution to the system of equations. If you have any questions, please feel free to leave them in the comments below. Now let's consider the two special cases. What method do you suggest to graph these equations? The first equation is given in slope-intercept form, so you can use the y-intercept and the slope, while the second equation is given in standard form, so you can use the intercept method. The y-intercept of the first equation is the point 0, 5, and the slope is -4/3. As we did in the previous example, we will start by plotting the y-intercept, which is located at 0, 5. Slope is rise over ran, and in this case, it is -4/3. You can place the negative sign in the numerator. It will not change the value of the slope since they are equivalent fractions. The key concept to remember is that when the rise is positive, we move up, and when it is negative, we move down. In this case, since the rise is -4, we move 4 units down. Similarly, when the ran is positive, we go to the right, and when it is negative, we go to the left. In this case, the ran is +3, so we go 3 units to the right. Now, starting from the y-intercept, move down 4 units, then move to the right 3 units, and plot the second point. Let's add one more point. Starting from this point, move down 4 units, and move to the right 3 units, and plot the third point. Then, connect these points with a straight line. Now, let's move on to graphing the second equation using the intercept method. First, let's find the x-intercept. Set y to 0 and solve for x. 3 times 0 equals 0, so we are left with 4x equals -12. Dividing both sides of the equation by 4, we get x equals -3. So, the x-intercept is -3, 0. Next, let's find the y-intercept by setting x to 0 and solving for y. 4 times 0 equals 0, and we get 3y equals -12. To isolate y, divide both sides by 3, giving us y equals -4. Therefore, the y-intercept is 0, -4. Now, plot the x-intercept, which is located at -3, 0, and the y-intercept, which is at 0, -4. Then, connect these 2 points with a straight line. Notice that the 2 lines do not intersect, they are parallel lines. If the lines of the 2 equations are parallel, then the system has no solution. Finally, let's consider the case where the system of equations has infinitely many solutions. Please feel free to pause the video and give it a try. The first equation is given in standard form, so first, we will find its x and y intercepts. To find the x-intercept, set y to 0. 5 times 0 equals 0, and we get 2x equals 10. Divide both sides by 2 to isolate x. 10 divided by 2 is 5. So, the x-intercept is 5, 0. To find the y-intercept, set x to 0. 2 times 0 equals 0, and we have -5y equals 10. To isolate y, divide both sides by -5, giving us y equals -2. Therefore, the y-intercept is 0, -2. Next, plot the points on the graph. Plot 5, 0, which is the x-intercept. Plot 0, -2, which is the y-intercept, and then connect them with a straight line. Moving on to the second equation, which is in slope-intercept form. The y-intercept is at 0, -2, and the slope is 2/5. Start by plotting the y-intercept. Slope is rise over ran, and in this case, it is 2 over 5, which means the rise is 2 units up, and the ran is 5 units to the right. Starting from the y-intercept, move up 2 units, then go to the right 5 units, and plot the second point. You have likely noticed that both points lie on the line of the first equation. When you connect these points with a straight line, it perfectly aligns with the first line. So, the line of the first equation and the line of the second equation are the same. They coincide perfectly. If the lines of the two equations are coincident, then the system has infinitely many solutions. This means that any point on the lines satisfies both equations. In conclusion, when solving a system of equations graphically, first graph each equation on the same coordinate plane. If the lines intersect, the point of intersection is a solution to the system of equations. If they are parallel, the system has no solution. If they are coincident, the system has infinitely many solutions.
Substitution method can be used to solve system of equation. So you solve one equation for one of the variable, then substitute the new form of equation into another equation for the variable. So to solve system of equation using substitution method, follow these steps. Step 1. Solve one equation for one variable. So choose one equation and solve it for one variable in terms of another. Substitute the expression found in step 1 into another equation. Step 3, solve for the remaining variable. Solve the resulting equation to find the value of the variable. Substitute back, so you use the value found in step 3 to substitute back into an equation from step 1 to find the value of the other variable. Then you write the solution as order pair, as you see in there, and then verify your answer. So substitute both value back into original equation to ensure it satisfies the equation. So solve the following. So you have 3x minus y equals 6 and negative 4x plus 2y equal negative 8. So solve the first equation for y. So 3x minus y equals 6. So we're solving for y. So we subtract both sides, 3x from both sides. And then I divide both sides by negative 1. Substitute this value for y in the second equation. Negative 4x plus 2y equals negative 8. So anywhere y is, I'm going to put 3x minus 6. So in this equation, negative 4x plus 2y equals negative 8. So you're going to end up with negative 4x plus 2, and the y beside the 2 end up being 3x minus 6 equal 8. Then I use distributive property, so 2 times 3 give you 6x, 2 times 6 give you negative 12. And then I simplify the left side, meaning that negative 4x plus 6x, you're going to end up with 2x minus 12 equal negative 8. Then 2x, then I add 12 to both sides, so that cancel, and then 12 minus 8, then I'm going to get 4, so 2x equal 4. Divide both sides by 2, and you get x equal 2. Then I'm going to substitute x equal 2 into the first equation to solve for y. I end up getting 0. And our computation have produced a point 2, 0. Check the point in the original. So first equation, 3x minus y equals 6. Yes. And the second equation is true. So that is how you do substitution method. So here are some other examples. So solving a system of a linear equation by substitution method. Solve one of the equation for a variable. Substitute the expression from step 1 into another equation. Solve the new equation. Substitute the value found in step 3 into either equation contain both variables. Check the proposed solution in the original equation. So solve the following using substitution method. So y equals 2x minus 5 and 8x minus 4y equal 20. Since the first equation is already solved for 1, substitute this value into the second equation as you see in there. So replace y with the result from the first equation. Then use distributive property, 4 times 2, 4 times a 5, you get negative 8x plus 20 equal 20. And simplify left side, you get 20 equal 20. So consider the following system of equation. So 2x plus y equal 10 and x minus y equal 1. So from the second equation, we solve for x, and x become x equal y plus 1. Substitute x into the first equation, x which is y plus 1, so you end up with 2y plus 1 plus y equal, so you end up with 2y plus 2 plus y equal 10. So you add your y's, you get 3y plus 2 equal 10. Subtract 2 from both sides, 3y equal 8, divide by 3, and then you get y equal 8 over 3. So number 4, substitute back. So you substitute y back into the equation for x. So you solve for x, and you end up with 11 over 3. Then you write the solution as order pair, as you see in there, 11 over 3, 8 over 3. And then afterward, you substitute back into to verify your solution. So substitute back into the original equations and see if you get what they equal to. So here they substitute back both order pair, and the answer is true.
The coefficient of the x variable in the first equation is 1, making it easier to isolate x in the first equation. So let's go ahead and do that. Add 3y to both sides of the equation. These cancel out, and you get x equals negative 9 plus 3y. Now that we have x by itself, the next step is to substitute this expression into the second equation for x. That is why it is called the substitution method. As you can see, we now have an equation with just one variable, and we know how to solve this, right? First, let's distribute the 2. 2 times negative 9 is negative 18. 2 multiplied by 3y equals 6y. Then, combine like terms. 6y plus 7y equals 13y. Then, add 18 to both sides of the equation. On the left side, the 18s cancel each other out, leaving us with 13y. On the right side, 8 plus 18 is 26. Now, to isolate y, divide both sides by 13, and you get y equals 2. Now that we have the value of y, the next step is to find the value of x by plugging in 2 for y in this equation, which is basically the first equation solved for x. 3 times 2 is 6, and negative 9 plus 6 is equal to negative 3. Finally, write your solution as an ordered pair, negative 3, 2, with x equal to negative 3 and y equal to 2. If you were to plot the graphs of these two equations, the lines would intersect at a point negative 3, 2. We can check that the ordered pair is a solution to the system by substituting it into both original equations. Substitute negative 3 for x and 2 for y. In the first equation, 3 times 2 is 6. Negative 3 minus 6 is negative 9. In the second equation, 2 times negative 3 is negative 6, and 7 times 2 is 14. Negative 6 plus 14 is 8. As you can see, both equations are satisfied, confirming that the ordered pair negative 3, 2 is indeed the solution to the system of equations. Now, let's try the second example, where the second equation is already solved for y. Since y is already isolated in the second equation, we just need to substitute this expression for y into the first equation. Now let's solve this equation for x. First, distribute the 2. 2 times negative 4x is negative 8x. 2 times 1 is 2. Then, combine like terms. 11x minus 8x equals 3x. Now subtract 2 from each side of the equation. Cancel these out. 14 minus 2 is 12. Now, divide both sides by 3 to isolate x. And you get x equals 4. Now that you have the value of x, the next step is to calculate the value of y. You can do that by plugging in 4 for x in the second equation. Negative 4 times 4 is negative 16. Negative 16 plus 1 is negative 15. Therefore, the solution to this system of equations as a coordinate pair is 4, negative 15, with x equals 4 and y equals negative 15. In the next example, both equations are solved for y. Please feel free to pause the video and give it a try. Because both equations are already solved for y, you can substitute one into the other. You can substitute this expression for y in the second equation or this expression for y in the first equation. It doesn't matter, you will get the same result in both cases. Let's substitute 2x plus 8 for y in the second equation. Now, to solve this equation, start by clearing the fraction. To do that, multiply both sides of the equation by 5. Then, distribute the 5 on the left side of the equation. 5 multiplied by 2x equals 10x. And 5 times 8 is 40. Then distribute the 5 on the right side of the equation. 5 times 3 over 5x equals 3x, right? And 5 times negative 6 is negative 30. Now, to get the variable on one side and the constant on the other side of the equation, subtract 3x from both sides, and at the same time, subtract 40 from both sides of the equation. On the left-hand side, these cancel out, and 10x minus 3x is 7x. On the right-hand side, cancel these out, and negative 30 minus 40 is equal to negative 70. Now to isolate x, divide both sides by 7. And you get x equals negative 10. Next, plug in this value of x into the first equation to find the value of y. 2 times negative 10 is negative 20. Negative 20 plus 8 is equal to negative 12. Therefore, the solution to this example is negative 12, negative 10.
That can be used to solve system of equation or simultaneous equation is called addition, arithmetic, or elimination property. You multiply both equations by the number that will allow you to combine two equations and eliminate one of the variables. So to solve system of equation using the elimination method, follow these steps. So first, align the equation. So write the equation in standard form like ax plus by equals c, Make the coefficient of one variable opposite. So adjust the equation if necessary so that the coefficient of one variable are opposite. This might involve multiplying one or both equations by a constant. Solve for the remaining variable. After eliminating one variable, solve for the other variable. Then you substitute back again. So substitute the value found back in one of the original equation to find the value of the other one. Write the equation as a harder pair, as expression and solution x, y, like a coordinate. And then you verify your solution, substitute both value back into original equation to check for accuracy. So example, solve the following system of equation using elimination method. 6x minus 3y equal negative 3 and 4x plus 5y equal negative 9. Multiply both sides of the first equation by 5 and the second equation by 3. The reason why I want to eliminate the y's. So both y's must have the same number to get eliminated. So the 5 times everyone in equation 1, you get 30x minus 15y equal negative 15. Second equation, which is going to times by 3, so the 3 is going to times the 4x, the 3 is going to times the 5y, the 3 is going to times the negative 9. You end up with 12x plus 15y equal negative 27. So you realize that both y's have the same number now. So negative 15y and plus 15y. So we're going to eliminate them. Combine two results by eliminating the variable y, as you see in there. So the y get eliminated, and then you are going to add. So this is a trick. Once they have different sign, you're going to add the solution. And if they have the same sign, you subtract. So 30x plus 12x give you 42x. 15 minus 15, we should give it 0. So the y's are eliminated. Equal negative 15 plus negative 27, negative 42. You divide both sides by 42 and you get negative 1. Substitute that negative 1 into the equation now. Any of the equation. And then you replace the x value with the negative 1 as you see in there. So 6 times the negative 1 minus 3y equals negative 3. So negative 6 minus 3y equal negative 3. And then you're going to simplify the left side, then add 6 to both sides and simplify. And you end up with negative 1 again. Our computation produce a point of negative 1, negative 1. So check the point into the original equation now. So as you've seen, I'm doing it and they end up to be true. So the answer is negative 1, negative 1. So solving this, remember we write each equation in standard form, eliminate the fraction coefficient. If necessary, multiply one or both equation by the number so that the coefficient of the chosen variable you chose are the same number or opposite. And then you add the equation. If they have the different sign, you add. Same sign, you subtract. That is when you're eliminating. So you have to watch what you eliminate. So the thing you eliminate, if they have a different sign, that means you're going to add everybody. If they have the same sign, you subtract. Find the value of one variable by solving equation by step 3. Find the value of second variable by substituting the value from step 4 in either original equation. It doesn't matter. Check your answer back into the original equations them. If you get fraction like this now, with 2/3 x plus quarter y equals negative 3/2 and a half x minus a quarter y equal negative 2. First, multiply both sides of the equation by the number that will clear the equation out of the equation. Clear the fraction out of the equation. So you have to get rid of the fraction first. So multiply both of each equation by 12. You don't have to multiply each equation by the same number, but in this case, it will be convenient to do so. So first equation, when you times that by 12 now, so multiply both sides by 12. I simplify, you get 8x plus 3y equal negative 18. Second equation, multiply by 12, both sides by 12, then you simplify both, I get 6x minus 3y equal negative 24. Combine each, as you realize, 3y and negative 3y, you're going to eliminate that. So we're again, once you have the same sign, what if they have different sign and you're eliminating the 3y and both of them have the same sign, you will subtract. But in this case, you have a different sign, so you're going to add the equations. So 8x plus 6x and then 18 plus 24, you get negative 42. Divide both sides by 14 and you end up with negative 3. Substitute each for x in the original, so y is equal to 2, and then check point in the original equation. So I'm doing it in the original equation. The answer is true. And in the second equation, the answer is true. So the answer is -3, 2.
Plus y is equal to 5, and 3x minus y is also equal to 5. So how can we find the value of x and y? By the way, whenever you have two variables, you need two equations to solve it. To use the elimination method, we need to add the two equations. Notice that if we add the two equations, the y variable cancels. Y plus negative y is equal to 0. 2x plus 3x is 5. So therefore, 5x is equal to 5 plus 5, which is 10. So now we could find the value of x. What we need to do is divide both sides by 5. 5 divided by 5 is 1. 1x is the same as x. And 10 divided by 5 is 2. So x is equal to 2. Now that we have the value of x, what we need to do is plug it back in into one of the original equations to get the value of y. Let's use the first one. So let's replace x with 2, not 1. And let's find the value of y. 2 times 2 is 4. So 4 plus y is 5. Now if we subtract both sides by 4, we can get the value of y. So y is equal to 5 minus 4, which is 1. So as an ordered pair, we can write the answer like this: 2, 1. X is 2, y is 1. Now let's work on another example. Let's say that 5x plus 4y is equal to 22. And also 7x plus 6y is equal to 32. Feel free to pause the video and work on this example. So we can either cancel x or y. Let's cancel the y variable again. So we need to change this equation, the two equations, such that when we add them, the y variables will cancel. So first, we need to find the least common multiple between 4 and 6. Multiples of 4 are 4, 8, 12, and 16. Multiples of 6 are 6, 12, 18. Notice that the least common multiple is 12. So therefore, I'm going to multiply the first equation by 3 so that the 4y will change into positive 12y. The second equation, I'm going to multiply by negative 2 so I can get negative 12y. Positive 12y plus negative 12y adds up to 0. So let's go ahead and do that. So everything in the first equation we need to multiply by 3. So 3 times 5x is 15x. 3 times 4y is 12y. And 3 times 22 is 66. Now let's multiply everything in the second equation by negative 2. Negative 2 times 7x is negative 14x. Negative 2 times 6y is negative 12y. And negative 2 times 32 is 64. Well, negative 64. Now let's go ahead and add the two equations. 12y and negative 12y will cancel. They add up to 0. 15x plus negative 14x is 1x. And 66 minus 64 is 2. So therefore x is equal to 2. So we can get rid of this stuff. Now let's use the first equation without the 3 involved. Let's replace x with 2, and then let's find the value of y. 5 times 2 is 10. Next, we need to subtract both sides by 10. 22 minus 10, that's 12. And 12 divided by 4 is 3. So y is equal to 3. So the solution is 2, 3.
So using the inverse of a matrix, write the system in matrix form. For the system, it's a AX equal B. So find the inverse So find the inverse of the matrix A. So you calculate the inverse A inverse if it exists for a 2 by 2 matrix. I remember that A is the numbers from the equation, B is the result, and X is the variables. So here, to find the inverse of a matrix, remember you have to find the determinant first, then you switch the thing. To find the inverse is 1 over the determinant, and then you switch the sign of B, C, change the sign of them, and then A and D switch position. So here you have A equal 2, 3, 1, -1. So determinant is 2 times -1 minus 3 times 1. So -2 minus -3, you get -5. So 1 over -5. Then afterwards, we're going to change the sign of BC. So here they are positive, so they become negative. And then the 2 and the -1 going to switch place. So that is how you do inverse matrix. Multiply the inverse by B. So remember, you're going to do row by column. And when you multiply, this is the answer you get. You're supposed to end up with 12 over 5 and 2 over 5.
Solve a simultaneous equation, something of this format, by using matrices. So how do we do this? Well, first of all, make sure you have got equations like this in this format. They've got an x term, then a y term, and then it equals a constant on the end here. And if that's the case, then we can represent this by the following matrices. We can say 5 here and -2. We just take the x and y coefficients. And then for the bottom line here, we take 7 and 6. So just put 7 and 6 there. And then we multiply this matrix by x and y. And if you do in the usual way, rows by columns, can you see that this generates 5x minus 2y. Look, 5 times x, and then we would do minus 2 times y. And for the bottom row times this column here, we'd have 7 times x plus 6 times y, generating this part of the second equation. And we can equate this then to these values here, because we would have 5x minus 2y would equal 16. And then when it came to the bottom row times this column, 7x plus 6y, we know what it gives us. It gives us minus 4. So this is the matrix representation then of this simultaneous equation. It's just a case now of how we go about working out what x, y are. So let's just step to the side for a moment and just think about how we can do ones like this. We're always going to have a matrix here. Let's suppose that matrix is called A. And we're going to multiply A with the matrix xy. And it's going to always be equal to these two values here. Let's just say, well, in this example anyway, it's 16 and minus 4. So we'll put those in there, 16 and minus 4. A and B, if you like, in general. Now to solve this equation here to get xy, what we need to do is multiply both sides on the left by the inverse of the matrix A. In other words, A minus 1 there, multiplied by A, multiplied by x times y, would give us the inverse of A multiplied by 16 minus 4. And we should know that the inverse of a matrix times A is the identity matrix I. I'll just write it in anyway. We'd therefore have I multiplied by xy equals the inverse of A multiplied by, in this case, 16 minus 4, or whatever your equation has. Now, the identity matrix times any matrix leaves it unchanged, a result that we should be familiar with in early videos that I've done for you. So we're just left with xy equals the inverse of A then multiplied by 16 minus 4. And this is the result that we always are going to use. If we want to find xy, all we need to do is multiply 16 minus 4, whatever values we've got here, by the inverse of this matrix. And this matrix must be on the left of these values, okay, like we've got here. So, assuming that I'm familiar with this, then if I was answering this question, I would want to work out, first of all, what the inverse of this matrix is. So I'm going to call it A. So I'd say let A be that matrix. A equal the matrix 5 minus 2, 7, 6. Now I'm assuming that you're familiar with finding inverses of matrices, 2 by 2 matrices. If not, just go on my website and look in this series under inverse matrices and you'll find an explanation there. But we had to find out the determinant of the matrix A. Remember, the determinant of the matrix A was to multiply 5 and 6 together and then subtract 7 and times minus 2. So if we do that, we get 5 times 6, which is 30, then subtract 7 times minus 2. Subtract then minus 14. What does that give us? It gives us 44. So when it comes to working out what the inverse of A is, we can say therefore the inverse of A is equal to, and it was always equal to 1 divided by the determinant of A, so that's 1 over 44. And then what we did was we switched these two elements around, so 6 goes there, 5 goes there, and we change the sign of these two elements, so that's minus 7, and then changing the sign on the minus 2 just gives us the 2. So there's our inverse matrix. We could write this as 6 over 44, 2 over 44, minus 7 over 44, and 5 over 44. It's up to you, but I'm just going to leave it like this. I find it easier for problems like this. So by this idea then, it means that therefore xy, okay, is going to equal the inverse of A. Let's just put it then as 1 over 44, and then 6, 2, minus 7 and 5, and we multiply this by 16 minus 4. So 16 minus 4. And so the first thing I'd want to do now is just leave the 1 over 44 there, and we'll multiply 6, 2 minus 7, 5 with the 16, 4. That's going to give us a matrix, something like this. We're going to do 6 times 16, which is going to be 96, and then add it to 2 times minus 4, which is minus 8. So you've got 96 minus 8, and that gives us 88. Lastly, we do minus 7, 5 times 16 minus 4. So that'd be minus 7 times 16, which is minus 112. And then add that to 5 times minus 4, which is minus 20. Minus 112 minus 20 is minus 132. Now I can take 1/44 of each of these two values, divide them by 44 in other words. And that means that I end up with 2. 88 divided by 44 is 2, and then minus 132 divided by 44 is minus 3. So you can see that xy equals 2 minus 3. So at the end of the day, what we have is therefore x equals 2 and y equals
Real-life
minus 3.
application and system of equation.